Hey, hello everyone. Welcome to the lecture 10. Today is the last part of the Literable lecture. So lecture 10, Literable 3, and there's no matching in C++ at DVC. So let's get started. So today we mainly talk about two objects. One is called iterator and one is called generator. So let's get started. So iterator is moving bookmark in an iterable. So what does it mean? Suppose you have a book, and then when you read the book, you suppose a book is iterable. So it has a lot of data, like each page can be a number, and then I have a lot of pages. And the bookmark is like whenever you read the book from the first page to the last page, sometimes you need to take a break or something. And then you can use a bookmark to mark where you live from the last time you read the book. Suppose I read from the first page to the 20th page, and then I want to take a nap. Then I will put a bookmark at the page 20. And then each time when you start reading the book again, you start from 20 and then go to maybe 40 and 50, and then bookmark will stop there as well. So suppose book is a list, iterable, and then the bookmark is the iterator, like looping through from the first to the last. So iterator returns the element it just goes by. Suppose I have a list 1, 2, 3, and in order to create an iterator, you will use um, iterator with parentheses. So here one is an iterator. So one is will be, suppose it is reader, and this is like to convert something into an iterator. Convert like to create something or to convert something into an iterator. Same as like when you try to make a list or a tuple, uh, you will use the name list or tuple, and the same as an iterator. I think this is the only way you create an iterator though. Um, yeah, one of the ways. And then you have an iterable inside, showing that you are creating the bookmark for that iterable object. So this is an iterator, and iterator is a variable. Like I'm using an equal sign to let the variable name one bound to iterator, which is looping through the list. So iterator is also variable. So for here, the iterator is one. And access the iterator with next. Like every time you want to move the bookmark as you read the book, um, like I think you will hold the bookmark onto your hand, or maybe in a book every time you read from 1 to 20, like you go for each page, and then the bookmark will be staying at page 2, 3, 4, 5, etc. as you read the book. It will stop to take a rest at every page until you think sometimes you want to take a break, and then the bookmark will be left there. So the next is like when you try to hold the bookmark in your hand as you read the book, try not to like try to remember, oh, I also still have a bookmark. So each time it will follow you to read the book. So this is an example of how to use iterator. Suppose I have a list 1, 2, 3, and 1, I use it to create an iterator of list to create like to make a list, to make a bookmark of the list. So next one, so I'm having the list. So uh, this is this can represent the bookmark or the iterator one, and then iterator of this, and then you hit next one, which means I will go from uh, go from the first the first member of the iterable to the second member of the iterable. So and then when I loop through one, when I go past one, I will return the value one, like the zero place of the iterable. So it will be one. And next, I also still hit that. And then here is my arrow. After hitting the next one again, I will make the bookmark to be here after two. I also return two. So get two. And then next one, I want to still get the next one of the member of the iterable. So I will be after three. And then I will return three. So how about next one? Like I don't have any variables. So but I was still moving my bookmark, by moving my iterator, and then I will be outside of the range, outside of the uh, iterable. So there will be stop iteration. Stop iteration to show that your bookmark, like when you finish reading a book, you will put the bookmark out of the book because like showing that, oh, I have finished that. Maybe I have to return to the library or something, but the bookmark is mine. I have to keep that with me when I read the next book. So the arrow will be out of the book. Um, the iterator, like same as you keep the bookmark out of the book when you finish reading the book. You keep the iterator out of the iterable object. So it will be outside, and then it will return a message saying that stop iteration because we finished looping through this iterable. So um, actually, is iterator is how actually a for loop actually how a for loop works. So suppose I have for loop for I in a list. Suppose this is 1, 2, 3. So for I in list, um, every time I want to modify every member in the list. So suppose I will plus equals 5. So there will be an iterator inside the iterable. Every time I want to check out every member. So I will have an iterator, same as a bookmark in the book. I will have an iterator in the list, and then every time I hit the first value, I will try to check it out and modify it, maybe like according to your code. Um, and then each time I finish doing something with one of the members, I'll skip it to the next one. Skip it to the next one. Then I finish implementing with one, and then I was still executing. I was still executing. Check out the second member two. So I will modify two, and then I will make my bookmark, make my iterator go past two, and then three, and then stop iteration. When I do stop iteration, means that I finish looping through the whole list. And when I have stop iteration, it means the for loop is finished. So yeah, so this is actually how for loop works, because you can assume that there is an iterator inside the for loop. So to check whenever there is an iterable, it will check each member in the iterable, starting from the 0th place to the last place, checking out all the members. It will be like a bookmark. When you have stop iteration, it means you exit the for loop. Yeah. So here is a demonstration of iterator. So suppose I create list is 1, 2, 3, and then one is iter list. So one is the iterator. So list is 1, 2, 3, and then my iterator is in front of one, and then I will hit next one. So when I hit next one, I will return one because I go past the one, and then I return the value one. At the same time, meanwhile, the iterator bookmark will go past one and then change the position to be in front of two. between 1 and 2. And this time you also want to hit next one, want to type west one in your terminal, and then you get 2. You get 2 because you go past 2, and then you move the bookmark between into the range between 2 and 3. And next time you still want to hit, wait, yeah, you still want to hit next one, and then you return 3 because you want to go past 3, and then you return the value, you go past by. So, but for here, we still didn't exit the iterable because the next time, which position marks the end of the iterator, it is right out of the range of the list. To be exact, is actually um, outside of the square bracket, and then I will have a message. When I see the message, stop iteration, that means I already exit the iterable object. So I will stop iteration, and I will be out of the range of the list. But for right now, I'm planning to uh, append an element right after 3. Suppose I do this to append 4. And then I will have a new element in the iterable object in the list. So as you see, the iterator is actually after 3, but not outside of the list. So when I do list dot append, the iterator object, the bookmark, isn't out of the list. It's actually between 3 and 4, between the last old element and the new element. Because I still didn't exit the loop, so next time I will hit next one, it will actually display 4. That's because the bookmark isn't actually out of the range. Um, isn't actually out of the object. And whenever there's an object behind it, it can still move there and return the value. It's the same as I know there's a kind of notebook which is actually you can take the pages out and you can add some pages in. Suppose you have a bookmark and it's at the end of the notebook, but meanwhile, like suppose I'm doing final reviews and I have some notes I want to add it to the back of the notebook, and I will make the bookmark unmoved, and then I will add the pages at the end of the notebook. So for that moment, the bookmark isn't actually out of the notebook, but I added some final notes into that, which means that the bookmark will be between the final review notes and some old stuff. So whenever I want to read the final review notes, I still use the bookmark to check to check to check out every element, like to check out every page in the new stuff. So although I append something new, but the iterator isn't actually out of the range, I can still use it. So um, so next one is 4. I go past the value, return the value, and next one, I decided to exit the loop though. So I call next one. Um, so you have start iteration. So to remember, the iterator will be like this. It will be out of the range of the list, out of the range, out of the square bracket. So at this time, when I try to append 5, like um the bookmark isn't moving around 5 because it's actually out of the list. It's not between 4 and 5 anymore. So I the iterator will not go past 5. So because of that, it will not return 5. So next time you do next one, so you have start iteration again. Like this iterator will never go past 5. It will never move around 5 because um Like it's too late though. It's too late. Like suppose I already finished reading the book, reading a notebook, like which I can add and remove pages from, add in or remove pages. So the bookmark is actually out of the notebook. So and then whenever you add something there, like you already finished reading that. So if there's something added there you don't know, so you will not check that. So the bookmark will not looping through that anymore. But you can create another bookmark though. You can use another bookmark. So yeah, so the bookmark has left the list. So you will not have a return 5. And the question for you is stop iteration an error? This confused me a lot when I learned this, but actually the stop iteration is not it's not an error. Why? Because it only shows that iterator is out of the list. So it displays the message saying that okay, we have finished that. Like it's actually like reasonable like to check that out. Um, it's not like a typical arrow is like divide zero, divide zero arrow, and this like kind of unbearable, and this will crash the program. So this arrow is unbearable. But for stop iteration, it do not crash the program though. Like everything is well matched, and it do not crash the program. So it is not an error. Yeah. So as I said, you can create another new bookmark, even though you have an old bookmark looping through. Suppose you have a book and you are reading, you have finished two-thirds of the content and you have the bookmark I, and then your friend wants to borrow a book to read that, but he or she didn't start reading that. So he will use his own bookmark though. Like every time you borrow a book to him, he will read something and then he will read from the beginning, and these two marks do not influence each other, like it do not affect each other because like they're independent though. Suppose I have J is a new iterator. So next J will be 1, and then you move the bookmark around. So go past 1, return 1. And then for the old bookmark next I, it's between 3 and 4. So I go past 4 and return 4. So the bookmark be the new position between 4 and 5. So um, two iterators, like or two or more iterators, do not affect each other. They are actually independent from each other. So next time you borrow a book to your friend, like tell them not to mix up your bookmark, like use their own bookmarks. So so that like it will not interferes each other. So for iterator as well. Mm. So this is the start for iterator, and then we'll talk about generator. Okay, generator is also iterables. Like we have done a lot of iterables, from the very basic concept of a list, and then this is changeable, and then tuple is unchangeable, and then we learned about dictionary, accessed by keys, and also iterator. Yeah, iterator. Iterator is like actually to look through the other iterables, as I said earlier. So it can look through dictionary, it can look through tuple, it can look through list. Um, So generator is actually a kind of iterator. Like we already know uh, a method to create iterators, which is like we say iter, appended like iter, and then include we can include iterable object in the iter, and then it will convert it into the bookmark of the iterable object. And generator is actually um, another way of creating an iterator, and it is not it is not fixed though, to be honest. So iterator is like you have actually you already have an iterable object that is fixed and you just create a bookmark. But for generator, things will maybe changeable and flexible, and usually come as a function, but it works as an iterator. It can be accessed with the next function. Yeah, like uh usually a generator is a function, and then you put next, like you put the function into the next function. So it will still work as a normal iterator. But remember, generator is a kind of iterator, which is very important for our next step. Yeah. Character can be considered as an iterator, but it's a function object. Yeah. Usually come as a function. So let's see. When you, okay, it returns the iterator. Oh, yeah. So that's why it works as an iterator because it returns the iterator when the function gets called. Uh, an example of an iterator function. We usually use a keyword called yield. Yield. So suppose define next one. Is the U1, UX, and UX plus one. So I call next one, like next one is a generator function, and then I put one inside. So this is an iterator, and I use a next. So the next one of iterator is like it will use X first. What is X? X is one. And then um so when I call next, it will look through this function, and then it will hit the first yield statement. The yield statement returns the value, but it does not stop in the frame of the function. It will still continue as you do an iterable. So as you do interval, sometimes suppose you have one, two. When you return one, it doesn't mean you stop and return. It doesn't mean you it ends everything. That means I take a break after returning one. And then next one you call me, I return two, and then take a break too. Yeah. So next x is one, and then I call next x is x plus one. What is x plus one? X plus one is two. So when I call next x is stop iteration. Yeah, why is that? Because every time you call me, the, the execution will be next line, and I hit yield, and it's the end of the function, which means that I cannot return anything. Yeah, I cannot. So that means stop iteration. So yield is like yield an element such as integer and string. So the question is, in a function, what is the difference between return and yield? Like when you guys drive on the road, you see two common traffic signs. One is called stop, one is called yield. What's the difference between them? Like, okay, I'm not on behalf of DMV, but I can tell you is that stop sign represents when you go into an intersection, before entering the intersection, you must stop. Um, Although you may not see people around your car, maybe you don't see any cars on the road. For any situation, for any scenarios, you must stop before proceeding. Yeah, you must stop before proceeding. Although you didn't see anything on the road. Yeah, this is stop sign. Like after stopping your car, for a while, like for a few seconds, you can continue with your trip. But for U side is similar but very different though. Um, U side is like when you see people, when you are in when you're approaching the intersection, when you see people on the crosswalk in front of you, you must stop and wait for him to finish his crosswalk. And then maybe there's also a car around, and then they may have the right of way, and then you have to wait for them to go past the intersection before you can proceed. But if you don't see any people around you, don't see any people using the crosswalk, or like when you don't see any cars on the road, when you see U side, don't have to stop. Like when like you can just go straight even without even like stopping or maybe reducing to very low speed. It's okay. Like if you don't see people or cars out there, which may be in your way, you don't have to stop or slow down. So this is U sign. U sign is like whenever like when there's yeah like stop sign is like you must stop at any second at any scenario, and U sign like you only stop when you're necessary. So this is return and U sign. Stop and U sign. Stop sign can be like return in Python, and U sign is to be used in Python. So similar as traffic rule, when the program hits the return statement, as when you approach a stop sign, you must stop. As like the function must stop and return the value. And the program, with the program hits the U sign, hits the U statement, the function will still runs, but it throws out the hit value out of the function. So U sign is like you don't have to stop. The function will not stop. It will throw out the value it go past by, but it will not stop though. Yeah, it will not stop. You still run until you hit maybe some maybe the end of the function or maybe base case when you do when you have a recursion generator, and then you may like when you hit the base case you should stop though. Yeah. So the use side will only stop when you like the end of the function or maybe a base case. You usually mark the base case with also a return statement. So return statement stops the function. Use side does not stop the function, but they both return values. Yeah. So this is return statement and use statement. Yield a return example. Suppose I think this is okay. Yeah. So let's see. When you have countdown, like suppose I count down from 100. So while is 2 and then I ux, oh, let's do 10 though, or maybe, yeah, let's do 10. 10 is smaller, much smaller, so better for demonstration. So when you go inside while 2, like obviously this looks like this looks like an infinite loop. So ux, so when you call next of countdown 10, the first will u10, and then check if x is like I return the value, but I do not stop here. So when you go through a u sign in the intersection, you do not have to stop if there's no car people. Uh, so if x is greater than is equal to 0, so 10 is obviously not. So we will skip, and then x will be minus equal 1. So this will be 9. So while 2, u9, and then uh reduced by 1. So it'll be 8, you get 8, then 7, 6, all the way down to 1. Suppose I'm like, suppose here's 1, and then I'm minus equals 1. So when you go from like start from the while loop again, it will ux. X is 0. So it will ux. It does not stop here, but it will enter the if statement. When you enter the if statement, you return nothing. Okay. Oh, when I hit the return statement, that means that it will stop the function. It will stop the loop, and then to see what we return nothing though. So we just stop the loop, or we stop the generator. Yeah, we stop the generator function. Although we did not actually return something, but when you have return statement, it marks the end of the loop. Yeah, it marks the end of the iteration, and return means stop. Yeah. When I have u from statement, u from statement is like u an element each time from an iterable, such as list, tuple, and dictionary. So a u from example is like it's like this. So suppose I take in 0 into the u sample. Every time I call u sample, like next of U sample, I will have uh, I will act like an iterator. So I will start from here, and then first time you call me, I return 0. Second time you call me, return 1, 2, 3, all the way down to 5, and then stop iteration. So U from an iterable is actually the same as an iterator, but it's more like in a function type. So this is U from statement. So U from statement, U from statement can be used in recursion only if and only if the recursive call returns an iterable. So U from can be cooperate with recursion or a function call, as long as the function call returns an iterable. When you are not using an iterable after a U from statement, it will cause an error. Yeah, it's more like a non-type or wrong type together type error. So define with yield. Yield x if x is greater than 0, return like this is base case, and then yield from. Yeah. So yield from here is like a recursion. It's like a recursion, and then um let's see. Suppose I take in 10 and I will yield from 10 first, and then skip this and yield from with u x minus 1, and I take 9 inside. This is a generator. A generator is an iterable, so it's totally okay. Yield from appends you can append with an iterable object, so it's totally fine, and it's as the same as we do the countdown from the last slide. So it will do all the way down until oh wait, yeah, if x is greater than 1, it will stop though. Oh, so yeah, well, I don't know, like it should be less than though. Yeah, it should be less than. So when you do this, it's basically the same as you do all the way down when we do the infinite while loop from the last slide. So it will go from 10 to 0 and then return nothing, which means that stop. Yeah. With U function returns the generator. Hmm. So it is an infinite generator. Recursive is sample. U a number at the time that can be divided by the input without a remainder. Okay. So infinite can mod. So okay, why is it infinite? It is infinite. I guess that's because you don't have a base case. So it's a nested. Okay, it's a nested recursion. Define helper. U from helper x0. So CanMod is a generator, and then it returns a generator as well. And then the helper function generator is also iterable, is with iterator property, has a property of iterator. And let's see. Mm, yeah, suppose x is the input. Like I want to check if a number can be divided by x without a remainder. I think that's how that works. Yeah. Mm, so if you check from 0, if 0 mod x is 0 and u from number, and a u number, like u is integer, a string, you actually throws out a value. And then when you hit u from, it will not actually returns the value though. It will not actually returns the value immediately. It's like an iterator. You have to call that, and then it will act as an iterator though. So suppose I start with 0, and 0, suppose I take in 10. So every time I get into this generator, and then I have helper x number and u from, um yeah, and then I take in here and to check if statement if 10, yeah, 0 mod 10 is 0, so I will use number 0. Yeah, I will use number 0, and then I will hit the next one. Oh, u from is the recursion. So I will take it again. This time, the number will be 1. And to check the if statement, no. So I will not use that. I will not use that. Because I cannot enter the if statement. And then I will skip to if from u from the helper x number plus 1. So this is a recursive call, a recursion. So I'll take in, like as I said, if you not use any values when you hit u from, it will work like an iterator. So um, like in the generator, when you only when you hit the u from, only when you hit the u statement, you will return a value. If you have a u from, it's actually like um, they are trying to look through another list, not they are looking for a list. Yeah. So the u from is actually return a value. A u statement returns a value, but u from will not. And then like every time you just check each number by 1, and then you will actually having 10, 20 in a row. And yeah. And I have a question for infinite generator. Would it be the like maximum recursion error? It's actually no. That's because every time when you do u number, u number, the function will take a break. It will take a break for a while. Like previously, stop the function means that we'll make the function stop executing anymore. And we can actually find it back. We can actually look it back to the previous function because we end the function frame. But for yield, we do not end the function frame. So each time when you hit the use statement, it will take a break after returning the value. And next time you call it, it will still loop it again and then find the value and then take a break. Each time you find the value, take a break. Why is we have an infinite recursion error? Because we did not let it take a break and it will loop through again and again and eventually sell a lot of space. But for an infinite generator function, as long as we can make a good control of how many times you loop, like by calling how many times. So when you have an infinite generator, you may just call it maybe about 10, 20 times, and it will actually loop a lot. Yeah. But for recursion, because for typical recursion without a use statement or use from statement, it will like it will not be stopping. Like you can actually control it very well. You will not be stopping. It will loop through maybe 1,000 times, 10,000 times until you crash the program. So yeah, so infinite generator is totally fine as long as make a good control of how many times you want to loop. Yeah, like every time you hit the U, take a break for you. Yeah, kind of like that. So the next slide. Okay, okay, we have the practice. Yeah, practice the merge list, and then you how um use recursion to use the smallest number between the plugin two lists, and then use the next smallest number. So remember last time we have done with the merge list recursion. This time we change it into U. Will that be simple? Maybe. Let's try doing that. Let's see. So we have two lists. Uh, yeah, and I think each time just find the smallest of them, and then you can remove the smallest, and then you check. So the second smallest value between two will be the first smallest. Then it's like every time you return that, when you have like you're having two choices. One is you, the one is you from. You may use both of them, and use like you only return maybe the first one or maybe the smallest one of the list. and then you will remove that, and then you have U from. U from is actually append the iterable, and U from will now return the value immediately once you hit that. Yeah, you're trying to enter that doesn't mean you are doing that. Yeah. So trying to enter it that after entering that, you also have another U statement, and then you U a number again, and things like that. Yeah. So let's try doing that. Uh, let's see. Yeah, I think because yeah, suppose I have defined U function. Can do uh for this time you can try doing the base case for the first of all. So what's the base case? The base case is like uh to try to return this to stop. So suppose like if this one you can find this one is empty and the two is empty. So you return none. So for this time it's actually base case, and then um, because we already loop through every element in both lists. This is the base case. So how about recursion? Recursion part. So let's see. We have three situations for this for these three cases. The first one is if this one and this two are basically still having something, like suppose for the first step, suppose this one, these two are actually they are both not empty lists. So which means uh we'll find S1 uh minimum of this one. S2 will be minimum of this two. And it will try to compare that. If S1 is greater than S2, uh let's say smaller. So you will try to use S1. Yeah. And then S1 will be thrown out. Suppose I'm having this. When I do X is this U list, this one is two. For next of X, you one. So because one is the smallest among all, so you one first, and then you will remove one. This one dot remove S1. So Yeah, this is that stuff. So still the same else. Maybe this one is to be together will be the same. I don't know, but we don't have that here, so it's okay. So you will use S2, and then this two dot remove S2. So this is the U part, and we can use recursive leap of faith to find out the recursive call. We don't actually do aggregation here. I don't think we have to do aggregation here, so it's okay. But we should know that like after throwing that out, uh we have to believe that the recursive call returns the true iterable object. So we'll use from which appends the iterable object, and we have a recursive call. Recursive call. We have to make sure this is returning a iterable object. So you from we do you this one and this two. Um, do we have an infinite recursion here? I don't think so because we are actually remove the smallest number of this one and this two. So this will be totally okay because we are smallarizing the problem. We are making the problem smaller and smaller. So by doing this, we will not have infinite recursion. Yeah, and we also have the base case, which try to return, like use the return statement to stop the generation to generate from generating stuff. So this is when S1. This is when this one and this two still having. Yeah, this one and this two are still um, this one, these two are still not empty lists. But what about one of them are empty lists? So suppose if this, because for this step, we have the situation that both this one and this two are empty lists. So so for the stuff after this step, we will only check if either of them. If one of them are empty lists, the other one will not be an empty list because if both of them are empty lists, so this base case will be hit, and we will not go through the following codes. So we will only check either of them. Either of them is empty list. So if this one is empty, so like you can use as minimum of this two, and then this two will remove, you can use as, then this two will remove as. I can do else if, or maybe else if this two equals emptiness, and as is minimum of this one because this two is empty. We only for this one, and then we use as, and then this one dot remove, and then as. So we do else for the following object step. So yeah. So how about why don't I include the U from? Because in the else statement, that's because when I know this one and this two are empty lists, it doesn't mean I can still take into the recurse. I can. That means I can still take it into the recursive call. The recursion is totally fine. We'll do that. Like we will allow that until I hit the base case. Um, yeah, we can check it though. We can. Let's see. Oh, okay. Looks like it's okay. So we'll do access yield list uh to 198, and then 571 56. Okay, so next of one. Next of X. Okay, it will be one. How about next one? Okay, 5. Seems like we're doing okay. Okay, 56, the last step. Okay, 71. Yeah. So looks like I'm doing very well. So maybe the process is kind of like a bit sophisticated, but yeah, it's like the base thoughts about doing the generator problem. Yeah. So yeah, so this is the very last part of this lecture. And for next week, we'll be talking about data abstraction. Yeah, data abstraction is still very easy to understand. I will use some very basic examples to explain what data abstraction is. And yeah, so we'll see you next week. So this is the end of the lecture. Yeah. All right. Have a nice rest of the week. Yeah. Bye bye.